Assalamualaikum warahmatullahi wabarakatuh. Hi guys, welcome to part 2 of our chapter 6. The figures on the left side is the real circuit, and on the right side is the circuit diagram. The circuit consists of a battery and a light bulb. Battery and a light bulb. The battery pumps charge through the bulb and around the loop. Charge will flow from the positive terminal of battery through the bulb and back to the negative terminal of a battery. The important quantities for the light bulb are the current and potential difference across the bulb. The circuit is showing the ammeter and the voltmeter. Ammeter and the voltmeter connected to a circuit. As you can see in the figure at the right side, the circuit diagram, the ammeter is connected in series with the light bulb, while the voltmeter is connected parallelly with the light bulb. This is a photo of digital multimeter, which is a device that can be used to measure voltage, current, or resistance. This multimeter also can be found in the lab, so I believe you already know how to use this multimeter. Okay, we have a figure here on the left side. The figure is showing a conductor with a length of L. This is the L of a conductor. When a potential difference delta V is applied across the ends of the conductor, the current in the conductor is found to be proportional to the applied voltage. If the proportionality holds, we can write this relationship. Delta V equals to IR. The proportionality constant R is called the resistance of the conductor. R is defined as delta V over I. In fact, we define the resistance as the ratio of the voltage across the conductor to the current it carries, with the SI unit of volt per ampere, equivalent to the ohm. If the potential difference of 1 volt across a conductor produces a current of 1 ampere, the resistance of the conductor is 1 volt. For example, if an electrical appliance connected to a 100 volt source carries a current of 6 ampere, its resistance is 20 ohm. R equals to delta V over I. 120 volt divided by 6 ampere will give us 20 ohm of resistance. We can compare the concept of electric current, voltage, and resistance to the flow of water in a river. As water flows downhill in a river of constant width and depth, the flow rate depends on the steepness of descent of the river and the effects of rocks, the riverbank, and other obstructions. The voltage difference is analogous to the steepness and the resistance to the obstructions. Based on this analogy, it seems reasonable that increasing the voltage applied to a circuit should increase the current in the circuit, just as increasing the steepness of descent increases of the water current. Also, increasing the obstructions in the river's path will reduce the water current, just as increasing the resistance in the circuits will lower the electric current. Resistance in the circuit is caused by collisions between the electrons carrying the current with fixed atoms inside the conductor. These collisions inhibit the movement of charges in a similar way that friction retards motion. For many materials, Including most metals, experiments show that the resistance remains constant over a wide range of applied voltages or currents. This statement is known as Ohm's Law. Delta V equals to IR is Ohm's Law. In Ohm's Law, we understand R to be independent of delta V, the potential drop across the resistor, and I, the current in the resistor. A resistor is a conductor that provides a specified resistance in electric circuits. Ohm's law is an empirical relationship and is only valid for certain materials. Materials that obey Ohm's law, which means they have a constant resistance over a wide range of voltages, are said to be ohmic. Materials having resistance that changes with voltage or current are non-ohmic. Ohmic materials have a linear current voltage relationship over a large range of applied voltages, as we can see in the figure on the left side. Non-ohmic materials have a non-linear current voltage relationship, as we can see on the right side, the figure on the right side. One common semiconducting device that is non-ohmic is diode, a circuit element that acts like a one-way valve for current. Its resistance is small for currents in one direction, which is positive of the potential difference, and large for currents in the reverse direction, which is the negative potential difference. Its resistance is small for currents in one direction and large for currents in the reverse direction. Thank you for part 2.